Long before the advent of modern shipping, maritime commerce across the Indian Ocean operated at a truly industrial scale. Between the 1st century BCE and the 3rd century CE, the Indian subcontinent maintained a structural trade imbalance with the Roman Empire and West Asia. This is a solid gold Roman coin, excavated in South India. The inscription reads, Caesar, dating it to the height of the Roman Empire. The sheer volume of these coins indicates a massive, decades-long drain of Roman gold into Tamil ports. This one-way flow of wealth was the output of a sophisticated, decentralized economic algorithm. The system relied on 3 operational pillars: precision material science, decentralized corporate protocols, and an integrated logistical network. Treating ancient India as a sophisticated global supply chain reveals a system engineered to systematically absorb global wealth. The foundation of this export dominance was advanced physical chemistry. To manufacture what became known as Wootz crucible steel, local engineers combined black magnetite ore with precise organic carbon sources, specifically bamboo and avari leaves. This animation shows a sealed clay crucible placed inside a charcoal-fueled wind furnace. Sealing the crucible prevents atmospheric oxygen from interfering with the chemical reaction inside. As the internal temperature climbs, the intense heat forces the structural impurities to separate from the pure iron core, leaving the useless slag behind. The critical metallurgical reaction happens during the slow cooling phase. Iron carbide particles cluster together, forming distinct crystalline bands, a process known as carbide segregation. The result is a durable material holding an exceptionally high carbon content, between 1.5 and 2.0%. The clustered carbides create the distinct wave and ladder patterns visible on the finished surface. European metallurgists could not reliably achieve this exact carbon concentration until the Industrial Revolution. This precision extended beyond metallurgy. For textiles like Ajrak block printing, artisans executed a strict 16-stage process using natural dyes, carefully synchronized with the climate to ensure exact sun-drying times. Mastering these proprietary physical chemistries created a baseline of product quality that competing global markets could not replicate. Producing these materials in isolated workshops is one thing. Scaling them to meet transcontinental demand required specialized organizational mechanics. Rather than operating as isolated artisans, producers organized into the Shreni, an autonomous, legally recognized proto-corporation operating under its own bylaws and corporate seals. This documentation outlines the precise structure of the Shreni. It shows that these entities possessed advanced financial capabilities. Textual records from the period confirm they operated essentially as banks. They accepted deposits, issued loans at fixed interest, and served as financial trustees for public endowments. By pooling capital locally, these decentralized nodes financed raw materials and equipment independently. They did not rely on a central state bank to underwrite their operations. This node-based diagram illustrates a Shreni's integrated operational flow. Inputs like capital pooling and apprenticeships feed into a central financial structure, holding vaults and loans, which then yields outputs of quality sealed goods. Quality control was strictly mandated. The corporate seal stamped on a finished product acted as a verifiable guarantee of integrity as it moved across long-distance supply chains. The Shreni also integrated mutual aid. They provided social security for members facing illness and funded community infrastructure like temples and water storage tanks. They maintained a symbiotic relationship with the state. Royal officials, known as adyakshas, regulated trade and collected taxes, but they did not centrally command production. The Shreni system enabled rapid capital mobilization and massive scale, while remaining resilient through its network of decentralized, self-regulating nodes. Once manufactured and stamped, these goods required a physical distribution network capable of reaching overseas empires. To move materials across rugged terrain, merchants established a continental logistical backbone, connecting inland processing centers directly to the coast. This map traces 2 primary internal arteries utilized by merchant caravans, the Uttara Patha running across the north from Taxila to Bengal, and the Dakshina Patha connecting the Gangetic Plain down to the southern Deccan. Goods migrated down these land highways, steadily pooling into massive coastal port emporiums like Muziris in the west and Arikamedu in the east. The oceanic routing protocol was governed by physics. Merchants synchronized their sailings with the predictable cycle of seasonal monsoon winds, launching fleets across the Arabian Sea and the Bay of Bengal to reach Arabia, Rome, and Southeast Asia. The macroeconomic export strategy maximized efficiency by prioritizing high-value, low-weight luxury goods. Wootz ingots, silk, and pearls commanded extreme premiums in foreign markets while taking up minimal cargo space. In return, the incoming ships carried massive, heavy influxes of gold and silver. This constant stream of bullion aggressively monetized the Indian economy and elevated the merchant classes. By seamlessly integrating continental highways with precise oceanic monsoon cycles, the subcontinent turned global geography into a sustained conveyor belt for wealth extraction. 2,000 years later, the architecture of this algorithm integrates with the modern industrial complex. The modern globalized supply chain prioritizes immense speed and scale, but it often struggles with fragility and centralized bottlenecks. The ancient Shreni's autonomous structure closely mirrors today's push toward decentralized finance and cooperative enterprise models. Looking at these two systems side by side reveals a shared efficiency. Both rely on distributed nodes for capital pooling and peer-verified quality control, bypassing central points of failure. Furthermore, their production methods were engineered for carbon neutrality. Processes like crucible steel smelting and natural textile dyeing were adapted specifically to local climate rhythms and organic resources. Studying these historical mechanics provides validated, operational frameworks for the current transition towards circular economies and biodiversity-conscious production. Ancient India's global wealth was the product of a synergy between decentralized corporate governance and advanced materials science, a blueprint modern economics is only just beginning to rediscover.